AWS Lambda Function using container images. Hello, welcome to Pablo's Spot. I'm George, and this is the first of what I hope to be a series of videos where we explore together things in cloud technology. On this video, we explore this new way of running AWS Lambda functions using containers. Let's start exploring. So this is the AWS blog that came out on the 1st of December last year that provides information on how to set up your Lambda function using container. Very interesting blog, but for this project, we won't be going through the whole thing, but we're only interested in the Python part. I'll put a link on this blog on the description so you can have a look at the whole thing at your own time. But we'll just pick up the ones that are specific to what we're going to achieve today. So if I'm going to scroll down to the section for Python, which is here, and then we can start doing some work. So if I launch my terminal, let me adjust the font size. Hopefully that's clear enough. Yep. And then I do have, so you can put your code, if you're following through, you can put your code somewhere else, but in my case, I'm doing it in a workspace Pablo Spot directory. And then in here, I'm going to create another directory called Lambda container. cd to that new directory, and then launch my VS Code from here. What we can also do is we can grab our blog from here, put it on the same page, so we have a proper workbench on our desktop where everything's easily accessible. So we will put the terminal on the back of it. It'll be very convenient to have the page on one side and VS Code on the other, so everything you need is accessible. Let me adjust the size of the fonts on my VS Code as well, so you see what I'm doing. Hopefully that's big enough. We don't need the welcome page, so let's just close that. We can start with having a look at the Docker config file, which is here. See, one thing that I would have loved to be available in here is some kind of a copy button that would copy the whole thing, and then we can just paste it on our code. We'll just copy the whole thing. And then on my VS Code space, I'll create a new file in here called Docker file. And then save that contents in there. And then let me just toggle my Explorer so we can have a better view of the Docker config. I've seen this Docker config file. So it's actually doing a multi-stage setup. It's allowing, the Docker config allows for users to be able to set up their directory within the container itself, where they put all the code and workspace for the container, runtime version, as well as the Docker image base distribution version. So in here, the first stage, you can see that it's actually using a Python image based off Alpine. The secondary stage, that would, I think this is one of the main sections where it installs some build binaries, and then a later stage creates a directory from within that image based off what's being passed, in this case home.app. So it creates home/home/app from within the container itself, from within the image. And then it says here at line 31, copy app folder, all the contents, and dump that inside home app. So I think from our point of view, we need to have a directory in here called app. So what line 31 says, copy everything that's inside app into the image. So that's that. And then the final stage is building off the previous stage, and I think there's an extra step here where it downloads some kind of a runtime. So it says there AWS Lambda runtime interface emulator, and then puts that inside the image itself. But what's relevant to what we're doing is lines 49 and 51. So line 49, it says copy entry.sh into the root of the container. So what that means is we need to have entry.sh from our root Docker context. So in here, I need to have a file in here that's called entry.sh. We'll leave that empty for now. And then if we go back to our Docker file, line 51 says it's gonna run a command. What this means, so it looks like it's a Lambda function by itself, like the normal Lambda function that we know about. But what this means is it's calling an app.py, and from within that app.py is a handler function. And so I think what this means is we need to have from within app directory a file called app.py. So let me try to explain that a little bit. From stage 2 of the Docker config, we've learned that at line 31 it's copying all the contents of app directory. So what this means is it's going to copy app.py and dump that inside /home/dir. It's taking its time to actually load the IntelliSense. So it copies app.py into home app. And then the handler segment means I have to have a function in here called handler. And like any other Lambda functions that we know of, it has to accept event and context as parameters. And then for now, we'll just leave it empty. So we've saved all our changes, and we go back to our blog. So I recommend you guys go through and read the blog in its entirety, just so you see what other options are available out there. Because especially if you are more comfortable with Node.js than Python, there's a segment in there that's specific to Node.js. But in here, it says entry.sh. It executes the Lambda runtime interface client for Python. So we do have an entry.sh in there. So all we need to do is copy that and paste it there. I just realized there's actually a mention of app.py from the earlier parts of this section version of Python that is being used. So we can just reuse that same code that's provided in there. And then just get rid of that, save that. Okay, so there's another thing that I'd like to change. So what we have here is a call to the Lambda function, and then the Lambda function would return this string in here. But I'd like to be able to see some information from within the logs of the Lambda function, suggesting that the Lambda function is actually run from within a container. So what we're going to do is we will add a print command in here, and then copy the same message, and then let's modify this. Hello from AWS Lambda using Python in a container. Save that. This will all make sense once we get to the part where we test this Lambda function. But for now, just trust me that there's a use for that. So I think at this point, we are good to go. So what we need to do next is, so we've got everything ready. So I'm just gonna launch my terminal from within VS Code. Okay. One thing to note is that sometimes these simple things slip off when we start working on things. But remember, we do have entry.sh that we created here. It's a shell script, so it needs to be executed. So if we just run ls-l and look at entry.sh, you'll notice that by default the execution permission is not set. So I'm gonna change that to executable. So u plus x just means I'm going to make it executable to the owner of the file. If I want it to be executable to everyone, which maybe it makes sense to just do that. Before we do that, let me just list the file first. So you see, it's only executable to the owner of the file. If I go plus x, enter that message, check that again. Now it becomes executable to everyone. So that's that. And I think at this point, we're now ready to build our Docker image. So what I'm going to do is, my context is Lambda container. So this is where I'm going to issue my Docker command. So in here, I'm going to go Docker build. My context is my current directory. And then all I need to do is tag the image -t and maybe call this Docker container. And then let's just, so if I don't put a tag, this image is going to be tagged as latest. So we just tag it as 1. Oh, sorry. So one more thing. So there's a way of running Docker build, which is relatively faster than just issuing the command, and that is setting up your build kit. So in here, let me just recall that command and then come to the front. And I'm going to set up my environment variable called docker_build kit to 1, then run the command. So at this point, we just have to wait until the Docker image is built. So our Docker build is done and our Docker image has been created. So if we go and check, if we go now and check our image, so there it is, roughly about 60 MB, so not bad. Now if we go back to our blog, so I'm just gonna go and pull this out. So we'll start running our Docker image, issue that command, and our image is called Lambda container with a tag of 1. How to run the test locally. So we'll just copy the whole thing, and I think this is where we need the other console that we have separately. Okay, so let me expand this a little bit and paste our curl command and run that. The message that we expected to be returned by the Lambda function. And remember earlier we said we added an extra print statement from within our Lambda function itself. And so what that means is if we go to the Docker image, sorry, the Docker container itself, we should be able to see that message being printed in the log, which is there. Okay, that's good. That's pretty neat. Yeah, cool. So we know, so it looks like it's working locally, and then we see the message being printed in there. So let me just cancel this. Now that we have a Docker image that we've verified to be working locally, we're actually ready to move to the next stage, which is to spin up the infrastructure in AWS itself, and we will use Terraform to do that. So there's two components to this. One part is the creation of the ECR and pushing the Docker image to ECR, and then the other component, which is to create the relevant infrastructure to build the Lambda function in AWS. So in building the Lambda function itself, we will use Terraform to build that. But for the earlier segment, there's a few commands provided in here that would help create the ECR and push the Docker image to ECR, which is this one. So to be able to do this, you have to have an AWS account. I do have one, and I've also configured my system to be able to run AWS CLI. So if I go to my console, to my terminal, I do have a profile that's configured on my machine that has my AWS credentials. So that means my key as well as my secrets, which would allow for any API calls that's happening on the background when I run the AWS CLI. So on my console, on my terminal, I just go export AWS profile, and my profile is called admin. And then for me to verify that my profile is working, I just do a basic S3 AWS S3ls. That command is to list down your S3 objects, which is working. So now we go back to the blog. The first part, which creates ECR, so all I need to do is copy that segment in there, paste it on my terminal, and I'll call my repository Lambda container. Yep, so that's created. And then what I need to do next is to retag my Docker image so it follows the convention that's specific to AWS. So if I go here and list my Docker images, so what I need to do is retag lambda-container to the AWS specific tag string. So I go docker tag lambda container 1, and then I need to copy this bit here all the way to the end, and then I'll just modify the string. So what I need to change is, instead of latest, I'm gonna use the same tag, which is 1, and I change this to lambda-container, and then I need to change the region. So I'm using US East 1 as a default region on my profile, so I need to change that to US East 1, and I need to change this bit here, which is the AWS account, to this one here. And then run that. Now if I describe my images again, I'll end up with my original Docker image and then another one that's tagged using the AWS string. So you'll notice that the size is the same, and even the image ID is the same, because they all, so the first one is actually inherited from the second one. So the next bit here is to connect to the ECR itself to be able to push the Docker image. So let me copy the whole string. And then modify some parts in here. So instead of SA is, change that to US is 1. And then again, I need to change the account number, AWS account number that is, to this one. And then I think that's it. If I issue that, so what this does is it tries to establish connection to the ECR repository itself in AWS. So it says login succeeded, so we've managed to create a session with the ECR. All we need to do now is push the image to ECR in AWS. So it's, let me list down my Docker images again, and all I have to do is docker push and use that new AWS Docker tag. Okay, so the issue here is when I push, I didn't specify the tag. So by default, it's looking for the tag latest, but but my container is tagged with 1. So all I have to do is put :1 at the end, and then try that again. So we just wait until this is done. So our Docker image has been pushed to ECR successfully. Now what we need to do next is to start writing our terraform config files to fire up our Lambda infrastructure. So if I go back to my VS Code, just enable this page again and then push the terminal back. and then open my Explorer, and then in my root, I'll create a new directory in here and call it terraform. So inside terraform, I'm going to create a file called main.tf. When writing terraform code, you don't normally memorize all the syntax or all the attributes and arguments that's required to set up the infrastructure. I usually open up the Terraform registry documentation on next to my console, next to my VS Code, as a reference. So if we go to docs, and we actually need to look at AWS instead of Azure. So it's always handy to keep the API documentation next to your IDE, in my case VS Code, because this is going to be handy when you start writing Terraform. So if I just adjust the size of that page a little bit. Okay. So from within the AWS documentation, what we're interested in is the Lambda function. So we go and scroll down to that Lambda function section. And then from here, we're actually interested in AWS Lambda function. So just click that one. So this is the documentation for the AWS Lambda function. Again, I don't want to go through the entire thing. Then we'll just jump straight to the example. So what I usually do is I copy the basic example that's provided in the documentation. And then start fleshing out. So let's look at this example. Let me toggle my terminal for now. Take it out of the screen. So I think I need IAM role, so I'll just leave that as is. But what we need to look at is this section here for Lambda function. Because we're running container, I don't think we need to specify a file name, so we can get rid of that. Role is basically a reference to the IAM role that's provided in here. And then handler, we know from earlier that our handler is actually called app handler. Again, it's calling the handler function from within app.py. And then because we're not hashing any file, we can get rid of this source code hash. And then our runtime is, in this case, we just use Python 3.8 because that's the maximum version of Python that AWS Lambda function is supporting at the moment. We don't need any, we haven't set any environment variables, so we don't really need that. And then, sorry, just need to adjust the formatting a little bit. And then from this point on, I start going back to the documentation and then looking at the attributes that I need to add. So let's have a look. File name, we don't need. S3 bucket, we don't need. S3 key, I don't think so. Object version. Image URI, I think this one we need. It says the ECR image URI containing the functions deployment package. So I think we need that. So I go here and say image underscore URI. And then set that empty for now. What else do we need? Package type, the Lambda deployment package type, values zip and image. So I think we need to set this up. But instead of zip, we call this image. Function name, I think we need to change the function name, but we can do that later on. Handler, role, descriptions, layers, memory size. I think we can leave the rest pretty much the same. Yeah. Alright, so we go back to our own code. And then all I have to do is, I want to change my Lambda function and call it Lambda underscore container. Right? And then all I have to change in here is image URI. So in the documentation, it says it's the URI of the Docker image, which we push to ECR. ECR image URI. There's other better ways of doing this instead of hard coding the values. You probably should do it that way, just to make everything sort of proper. So what I need is a data reference to the ECR repository. So if I go back to my index and then go to ECR, and then I'm not creating any resource because it's already existing. So I have to go and look at data sources. So what I need is ECR repository. So again, I'm just going to copy that, put that on top of the Lambda function resource, and then remember I called my ECR Lambda container, so I just have to update that. And then in here, in my image URI, I'm going to say data dot AWS ECR repository dot service, not capital. So I'm referencing this object here. And then what I need is, I think, let's have a look at the documentation. I need the repository URL. Repository URL. And then I need to plug in the one at the end because I know it's tag one. So what I need to do is surround this with curly braces. Oh, hang on, sorry. Surround it with quotes first, and then surround it with curly braces, and then at the end add one. Sorry. So I surrounded the reference to the repository URL with curly braces and quotes, and then I need the $sign in front, and then :1. So what Terraform does with this syntax is it goes and tries to interpolate the value of this, and then it will then output from in the background. It will evaluate it to this value and then add 1 at the end. So we don't need the other image URI. Save that. Cool. The other thing is, because we're doing AWS in here, sometimes when you run your Terraform commands, it will end up asking you for some variables that's specific to your provider. So in AWS specifically, when you run your Terraform commands, it's going to ask you for default region. So we are going to suppress that prompt by adding a new file called provider.pf, and in here we just say provider AWS, and then we say region is this one. Save that, and I think we're ready to run our Terraform. So if I open my terminal on my VS Code, I need to run my Terraform commands inside the folder where the configs are. So in my case, they're all inside Terraform directory. So if I ls here, I need to cd inside Terraform. Actually, just so you see what happens, if I run Terraform init in here, actually let me just show you what version of Terraform I have, just so you can cross-check. Version 13.5. So if I run Terraform init in here, it fails because it says Terraform initialized in an empty directory. That's because Terraform tries to read any configuration files that sit on the directory where you run it from. So I need to cd into Terraform directory and then run my Terraform init. Cool. So Terraform init is done. So now I want to see how I want to see what resources are going to be spun up when I apply this configuration into AWS. So I run Terraform plan. So Terraform plan failed. Let's have a look at what the error is. It says ECR repository not found. So I think I know why ECR repository is failing in here. That's because we haven't set up AWS profile on this terminal. So if I go echo $AWS profile, it's empty. So in here, you just need to export AWS profile, close admin. So remember, when we run Terraform commands, especially plan and apply, it's trying to run AWS API calls in the background. So if you don't have any profile set properly on your session, it's not going to work. So you see, if I run Terraform plan again, so it looks like Terraform plan was successful, and it says it's going to add 2 resources, 0 to change, 0 to destroy. So we can then start reviewing the different resources that are going to be created when we run Terraform apply. So we've got IAM role, which is expected, and then the actual Lambda function. Cool. Good. So now, before I run apply, I want to output my plan to say some arbitrary value like out.tf plan. Nice. So in here, if I do ls, I've got out.tf plan in my list. So now, if I run terraform apply and use that output file from the plan, terraform apply out.tf plan. So it looks like our terraform apply completed successfully. It is, as the summary says, it has apply complete, 2 resources added. So at this point, we're ready to run some tests. Let's go AWS Lambda invoke region US is 1, which is our region. Function name, we call the function lambda dash container dash dash log type tail, and then we output the result. Oh no, let's just do that. We don't have the dash dash, so let's fix that. The following arguments are required. Output file. So we just go function name out. Let's have a look at what name we provided. So it's actually an underscore instead of dash, so that's why it's missing. So let's fix that. Cool. So there's a log result, but it looks like it's in base 64. So this is what I was trying to pull out. But if you look at the status code, it's actually returned as a good one. And remember, we actually spitted out the result into a file called out. So if I ls in this directory, I should have a file called out in here, which is that one. So we just view the contents of that file. And there it is. It's the expected return string that we set up in our Lambda function itself, which suggests that it's working. The other thing that we want to check is I'm actually interested to see what this log result shows, because remember, we added a print statement in our Lambda function, and so we should be able to see it from here. So what we can do is we can actually extract. So if I recall that function again, we can extract log result and then output that into text. Yeah, and then the result I want to base 64 decrypt it. So base 64 decrypt. There you go. So this is the actual log of the Lambda function. So we have 2 things in here. So we have the out, which is the return value of the Lambda function. So if we cut out, it contains this string, and we have the base 64 encoded log, which we just decoded, which contains this information in here. And you see the print statement that we put in our Lambda function is there. So it looks like everything is working. So there you go, guys. We finally managed to follow along the steps that's provided in the blog, and I think at this point, you're free to explore and expand further the functionalities that you've learned from here. So, Lambda function using container images. Pretty neat, hey? Let me know what you think in the comments below, and don't forget to give me some thumbs up if you find this useful, and subscribe to this channel. Until next time, remember, you learn more by doing. See ya.